Hello everyone, welcome back to High Tech Fun Study channel. So in this session we're going to discuss about class 9 science chapter 1, which is matter in the surroundings, which is on the chemistry sector. So let's get started. So this is the part 2. Do watch part 1 for knowing about what is matter, classification of matter. Okay, and we've also learned about the physical property on the modern scientists, how they classified matter on the basis of chemical properties and physical properties. In the physical properties, we have seen solids, liquids, and gas. We have seen properties also for them. So do watch part 1 for knowing about the states of matter and classification of matter and also definition of matter. So now let's get started with the characteristics of matter, whether it be solid, liquid, or gas. Any matter in the world, the characteristics, the four main characteristics, what are they? The first characteristic is that the particles of matter are very, very small. Alright, so they're very, very small. They're beyond our imagination. So they're very small, they're very tiny in nature. And the second characteristic of matter is that the particles of matter have space between them. So what is meant by space? Usually space means, if you see in a theater hall, for each and every seat, we don't think there would be that much space. Okay, at least some space would be there. So in the solids also, we told in the properties of solids in the part 1 that the solids do not have any interspatial gaps present between them. Interspatial gaps is different from normal gaps. They're having at least minimum gaps. So at least tiny small gaps between the particles of matter are there, even though they're solids, right? Solids, liquids, and gas, all the particles of matter have spaces between them. And the third characteristic of matter is that the particles of matter are continuously moving. What is meant by moving here? Moving means in motion. See, if an object is a rest position, it is at rest position. The rest position means if you take a ball, example, take a ball, and when you take a ball, you keep it in a position. Okay, it is not moving. Means it's in rest position. And if you kick it or if you throw it, what would happen? The ball is moving. When you see in a cricket, the ball, they will be moving. They will be throwing to the bat. So what would happen? The ball is in motion. It is moving. So when an object is at rest position, it starts to move. It is said to be in motion. So the particles of matter are continuously moving. And the fourth characteristic of matter is that the particles of matter attract to each other. So the particles of matter attract to each other. They are having attraction force. So these are the four characteristics of matter. So now we are gonna see experimental evidences for characteristics of matter. Means all these four characteristics, we're gonna see some experiments. Okay, evidences which are used to prove that these characteristics of matter are real, and they are proved for each and every state of matter, whether it be solid, liquid, or gas. So now let's get started. So for the first experiment for the first characteristic, we need potassium permanganate. So what is the first characteristic? Particles of matter are very small or tiny in nature. So for this, you need potassium permanganate. So potassium permanganate is a kind of matter. Take 2 to 3 crystals of KMnO4, means potassium permanganate, and dissolve in 100 ml of water. So after dissolving in 100 ml of water the crystals of potassium permanganate, means KMnO4, you would get a deep purple colored solution. Now take 10 ml of deep purple color solution from first beaker or test tube and mix it with 90 ml of water present in the second test tube to dilute it. So for the dilution process, we need to take 10 ml of this deep purple color solution from the first beaker or from the first test tube and mix it with the 90 ml of water which is present in the second test tube. So we need 9 test tubes for this activity. Actually 10 you need. Like you should use the first one, right? So you need 10 in the first beaker. You need water in which you'll mix the potassium permanganate KMnO4, and the other 9 you should do experiment, right? So this is what you should do. So for diluting the for diluting the 90 ml of water present in the second test tube, we need to take 10 ml of water present in the first 10 ml of deep purple color solution from the first beaker and mix it with this 90 ml of water which is present in second test tube. Now similarly, 10 ml of purple color solution is transferred to test tube 3 and again from the test tube 3 to test tube 4 10 ml is transferred. From the test tube 4 to test tube 5 10 ml is transferred. Like this from each and every test tube. Like from the test tube 5 to test tube 6 10 ml is transferred. The 10 ml of this deep purple color solution will be transferred. Now what would happen? As you can see here, this is given in the textbook. So as you can see here, when we add the crystals, like it will be like this, crystals of KMnO4. And when we transport 10 ml to each test tube till 9 test tubes, in the 9th test tube we find out that the purple color of the solution is diluted. So we conclude that each potassium permanganate itself must be made of millions of small particles which keep on spreading and imparting color to water molecules. So what would happen in the 9th test tube, when we see the color is light, okay, it's very lighter. Deep purple color solution changes into light color when we transport this into 9 test tubes. But what happens? What happens? The potassium permanganate will be made of millions of small particles which keep on spreading. That is why we observe the deep purple color solution when we add these crystals of KMnO4 in the water. We observe that these particles spread out. That is why at the end we see that in the 9th test tube the color is lighter because the particles spread out and they impart color to water molecules. So they impart the color to the water molecules. So though the color becomes light, it is still visible. So this shows that the particles of matter are very small or tiny in nature. So for the second characteristic of matter, which is the particles of matter have spaces between them, we need salt and water. Alright, so what you should do, the spaces between the particles of matter can be shown by performing the following experiment by using water and salt. So you need water and salt for this experiment. So take about 500 ml of water in a beaker. So in a beaker you need to take 500 ml of water and mark the level of water in the beaker. So you need to mark the level of water, how much level of water is there, right? So obviously it will be 500 ml only, right? So mark it and take 50 grams of salt and add it in the water by using glass rod. Stir it until it dissolves. So what you should do, 50 grams of salt you should dissolve in the water, and after that you should stir it until it dissolves, until the salt dissolves in the water. You should stir it with a glass rod. So glass rod is usually used to stir the chemicals or whatever, right? So you should stir it until it dissolves, until the salt dissolves in the water. So when the salt has dissolved, observe the water level in the beaker. So when the salt is completely dissolved in the water, you should observe the water level in the beaker. We will find that the level of salt solution in the beaker is at the same mark where water level was initially in the beaker. So usually what happens, the level would increase, right? Water level, because we added something into the water, like something, not only salt. If we add anything into the water, the weight increases and obviously the water level increases. But here salt, after dissolving also, the volume, the level of water is not increased. We will find that the level of salt solution is on the same mark where water level was initially in the beaker. So this salt solution, when we add salt into the water, it becomes salt solution. This means that even after dissolving 50 grams of salt in 500 ml of water, the volume has not increased. So the level of water is not increased even after dissolving 50 grams of salt in the 500 ml of water. So we conclude that the particles of matter have some space between them. So the particles of matter have space between them. So the particles of matter, they're magnified millions of times. When we dissolve salt in water, the particles of salt get into the space between the particles of matter. So the water has spaces between them. Water will be like having some spaces. Water particles, H2O particles, right? Water means H2O, hydrogen plus oxygen. So what happens, these particles of hydrogen and oxygen have space between them, and the salt, NaCl, sodium chloride, it will be getting into the space of water. So there will be no increase of the water level. So that is why the particles of matter have space between them. And now we will get into the third experiment, for proving the third characteristic, that is the particles of matter are constantly moving, they are in motion. So for that, the experiment, we need the incense stick and also copper sulfate. So incense stick means agarbattis, which we do have in our home, right? So the best evidence that the particles of matter are constantly moving comes from the studies of diffusion and Brownian movement or motion. So diffusion and Brownian movement or motion we will now discuss after these experiments. So there are two experiments, right? For the third characteristic of matter and the fourth characteristic of matter, we are having still two experiments. So after those, we will be discussing about diffusion and Brownian motion. So Example, this is the activity. So when we light an incense stick, means agarbatti, in one corner of a room, its fragments spread in the whole room quickly. So in one corner of the room, we will keep the agarbatti, but in the whole room, smell will come. The fragments will spread because the fragments will spread. We will absorb the smell in the whole room. If we even keep it in the one corner, this means that the particles of gases produced by the burning of incense stick move rapidly in all directions, mix with the moving particles of air in the room, and reach every part of the room quickly. Alright, so second activity, you can do two activities for this, that the particles of matter are constantly moving. For this characteristic, you can do two activities. So for the other activity, you need CuSO4 copper sulfate. So when a few crystals of copper sulfate CuSO4 are placed at the bottom of the beaker containing water, then water in the whole beaker turns blue slowly. Right? So when we add the copper sulfate CuSO4 at the end of the water, in some time only the whole water changes into blue color, copper sulfate color. Copper sulfate color is blue. Right? So if whole water turns into blue slowly. From the above activities, we conclude that the particles of matter are moving from a higher concentration to a lower concentration, which is called diffusion, and the particles are continuous in motion. So, diffusion means when the particles move from a higher concentration to the lower concentration, it is known as the diffusion. So, we'll be learning about diffusion now, okay? And we will see, after seeing the fourth characteristic of matter, we'll be learning about diffusion and Brownian moment. So what is the fourth characteristic of matter? It is the particles of matter attract to each other. They have some attraction force. So for this experiment, we need a piece of chalk, an ice cube, and iron nail. So there are some force of attractions between the particles of matter which bind them together. The force of attraction between the particles of the same substance is known as cohesion. So cohesion means what? The force of attraction between the particles of the same substance is known as cohesion. Okay, if we take a piece of chalk, a cube of ice, and an iron nail and beat them with the hammer. So you beat chalk piece with a hammer, it will break. If you beat ice cube with a hammer, it will melt and it will break. So when it comes to iron nail, what would happen? So you think what would happen when it comes to iron nail? Because the particles which are present in the iron nail have strong force of attractions. Due to this, the particles of matter attract to each other, and that is why the iron nail remains same. It might be bent, but it won't break that much fastly as chalk piece and ice cube break, because of the force of attractions present between the iron. It's very strong. The force of attraction present with the iron is very strong. Due to this, the particles of matter attract to each other. So we've learned about the four characteristics of matter with all the activities, right? So now we're learning about Brownian movement or motion. So Brownian movement, or we can also call as Brownian motion. Movement is known as motion. What is Brownian movement? The zigzag movement of the small particles suspended in a liquid or in a gas is called a Brownian motion. So now the particles of matter, they are very tiny. They are in motion, right? And they have space between them. They attract to each other. So actually the particles of matter, they don't have heads. Or I think they don't have heads. So what would happen? They don't have brains. Think they don't have brains in the heads. So what would happen? They don't move in a straight way. So there is no proper. I'll show you. So this is a straight line, right? So the particles of matter move in a zigzag way, like this and like this, like that. So why they don't move in a straight way? So this zigzag movement, whatever is there here, this zigzag movement is called a Brownian motion. So the zigzag movement of the small particles suspended in a liquid or in a gas is called the Brownian motion. So due to this Brownian motion only, the CuSO4 dissolves in the water completely and turns it into blue color. Okay, and the existence of Brownian motion gives us two conclusions about the nature of matter. What are those conclusions? That matter is made up of tiny particles and the particles of matter are continuously moving. Alright, so this is about the Brownian motion. So as you can see, the particles of matter are like moving in a zigzag way, right? Yes. So diffusion. What is diffusion? Out and mixing of a substance with another substance due to its motion of its particles is called a diffusion. So this is also the definition of diffusion. Also you can write the movement of particles from higher concentration to a lower concentration is called diffusion. So spreading out and mixing of a substance with another substance due to its motion, due to its movement of its particles is called diffusion, or even the movement of particles from a higher level of concentration to a lower level of concentration is called diffusion. The diffusion is a property of matter which is based on the motion of its particles, means movement of its particles. We saw in agarbatti, and also like in the incense stick, and also in the CuSO for copper sulfates, right? So how they spread out into the how this incense stick spread out in the air, the fragments of incense stick spread out in the air. If we keep it in the one corner, how? Because of diffusion, it spread out. Okay, because of the motion of the particles of incense stick, the diffusion happened and it spread out, and it mixed with the substance and it mixed with another substance, and due to the motion, it spreads out the whole room. And also in the CuSO4 the same happens. It diffuses into the water, so completely diffuses and it turns into the blue color slowly, the water, right? So the diffusion is a property of matter which is based on the motion of its particles, and the diffusion is fast in gases and slowest in solids. Because in the gases the particles, because in the solids the particles do not move much. Because the diffusion is fastest in gases and slowest in solids, because in the solids the particles does not move much, but in the gases the particles move very fastly, right? So what happens in gases, we saw in the properties of gas, right? So they move very quickly, they have so much space between them, but whereas solids they're packed very tightly, so that is why they cannot move. If they are packed very tightly, how can they move? But the gases, they are left out in the air freely, so they are left out freely, right? So that is why they move. And the solids, they cannot move much, the particles of solids. So that is why the diffusion is fastest in gases and slowest in solids, and in between in the liquids. So the diffusion in liquids is faster than solids. So the solid is slowest. Okay. So the diffusion in liquids is faster than solids, because liquids also have the gaps and spaces between them, due to which they can move the particles of liquids freely, like gases only. So the rate of diffusion increases on the increase of the temperature of a diffusion substance. So the rate of diffusion, whatever is there, it increases on the increase in the temperature of the diffusing substance. So when the temperature of the diffusing substance increases, the rate of diffusion also increases. So increase in the temperature, increase also in the diffusion. What is this known as then? Diffusion is, the rate of diffusion is directly proportional to the temperature. Alright, so this is about the diffusion. So this is the diffusion. So there's a high concentration, right? So this is the high concentration. So means it's like moving upwards, high concentration. Diffusion happens now, and what happens with the time? It moves into low concentration, right? So it moves into low concentration. So this is about diffusion. From the particles of matter, from a high concentration, they move to the lower concentration. It is known as diffusion. Alright, so this is all about today's class, and the next class next session we will discuss about the diffusion in different states of matter, solids, liquids and gases. We will learn each and every diffusion separately. Okay, so it's time to recap what we've learned today. We've learned about characteristics of matter, we have learned about experimental evidences about the characteristics of matter, and we've also learned about the Brownian movement or Brownian motion, and we've learned about the diffusion. Alright, so thank you for watching this video. If you like it, please hit a like, share with your friends and family members, and also comment your doubts and questions to me, and don't forget to subscribe and click the bell icon. Thank you for watching.